Great. I'm awesome. Let me pull up my presentation.
Okay, sounds great.
Good
And
morning, everyone. I'm not going to belabor the point that who I am because I've already been introduced. Yeah, so why the heck did we bother with this? Obviously, not many people in Alaska have dried kelp at any scale. And so we just wanted to get a feel for, yes? Oh, I just heard somebody. We just want to get a sense for what are the qualitative characteristics of kelp once dried? What does the process of drying look like? Maybe a short, exercise in the economics of drying. And so in order to do so, we utilize the KSMSC pilot plan.
Okay, got your email.
Somebody has their microphone on and it's a little disruptive.
I've just muted. I think we're all good.
Thank you. And so we utilized equipment at the KSMSC pilot plant. And I want to give a nod to our partners, Alaska Sea Grant, in this for letting us utilize this fantastic equipment and purchasing of this equipment, which included a pilot scale dryer here, as you can see, and this small mill to grind the kelp once it was dried. And yeah, we just know very little about the characteristics of kelp, especially Alaskan species of kelp and how they dry. Yes, there's kelp dried all over the world, but not our particular species. So we took a look at a few, of course, we did Saccharina latissima, the gold standard. We also dried bull kelp, and then we dried Eularia fistulosa or dragon kelp. And Alaska has a lot of challenges when it comes to drying. We have cold, wet environment, not conducive to drying. We have higher energy costs in some of our rural communities. So there were a lot of challenges, and I just hoped that this project, and so did Callie, would give us some insight into how this could work at any scale in smaller communities throughout the archipelago. And there's lots of industry interest in especially how to choose the right dryer. I think this is a question that we all ponder every day. They're expensive. We want to make good decisions. So hopefully some of the data collected in this project could advise and may help industry representatives make better choices when it came to dryers. Lots of education, again, needed. And that's what we did. So we looked at the science of drying. What are the variables involved? There's all sorts of things that control how productive your drying is, how efficient your drying is, things like the amount you're able to load into the dryer at one time. The layering is super important, how thick the layers are, because heat has to get into that product to dry it. So you can't have too thick a layer. You don't want to do too thin, then you're losing product volume. So looking at those sort of factors. But other things that people haven't really readily considered, which is like the ambient conditions outside of the dryer. You're pulling air into a forced air dryer. You have to heat that air. So what are the ambient temperatures? The relative humidity in the ambient space in which you're drying is also quite important, and that'll help, again, with heat transfer, but it can also deter product drying. So moisture in the air is very important. So we looked at those variables. This should lead into what you should ask a dryer manufacturer. So what questions do you ask them? Can you say, okay, I've got this product, how do we dry it? We just hope that what we did would better advise industry to ask educated questions. Costs are super important. That's the big one. What does it cost to dry? What's in the dried kelp? So we did a full heavy metals profile, microbiological safety profile, a whole thing. We ran numerous tests. We came up with a nutritional label for the kelp produced, including how do you work around iodine when it comes to, your daily allowance and your serving size. So lots of interesting questions there. What are the hazards associated with kelp? We've talked about heavy metals. There's also some occupational hazards involved. The dust that's created in milling could be a serious occupational hazard, and so there'll need to be technology added to a processing line system to address that particular hazard and take up dust, because in the air it's hazardous to people. It can be flammable and cause flash fires, some things that people aren't really considering when it comes to producing a dried kelp product. And again, nutritional labels, and then product spec sheets. And that's basically just something you provide to a potential buyer that gives the breakdown of the product, what it looks like, how it's packaged, and what's in it basically. So your nutritional label goes on there as well. And then we identified next steps and other research that would help formulate a better drying system for Alaska. So the major takeaways of the project, again, ambient relative humidity is actually quite a concern. So folks have contemplated drying, on a tent on a dock somewhere in coastal Alaska. Well, we have near, 90 to 100% relative humidity in a lot of cases, and we have cold temperatures. So, sometimes south of 50 degrees Fahrenheit. So not conditions conducive to drying. So maybe you need a space with a controlled environment to dry efficiently. Drying is expensive in a small batch system. Definitely the bigger you go, the more efficient it gets. But given Kodiak's power cost, this is only concerning power cost to dry. These numbers don't factor in labor, equipment amortization, any of these things. You're looking at about $1.72 a kilogram to dry, or 78 cents a pound roughly. So it's expensive. That's an additional cost to the product on top of all your packaging costs and labor costs and other things you're going to add on there. So, or even just the cost of buying the kelp from a farmer. So there's a lot of things to consider. There's occupational hazards, like I said, involved in milling. Kind of gets scary. You don't want to breathe a lot of kelp dust. Iodine and heavy metals. There's not a lot of good guidance out there for seaweed, something that we probably need to work on in kelps. So how do we address this in human food and animal feed products? And then allergens are a concern. Lots of little creepy crawlies. You can see some of these here that were picked out of kelp before it was dried, and a lot of them make their way through. So we did thorough allergen testing and found that there are enough levels of allergens to be a concern. The USDA doesn't set allowances for or tolerances for allergens in foods, but you're definitely going to have to declare that on the label because it's been my experience, there's no way to pick all those little guys out. So the next steps, we need to establish drying coefficients for Alaskan kelp species. This helps with the math, and it just could help with better modeling and designing dryers that are more efficient. We can use drying coefficients in those equations for other wet type products. There's a few out there from other studies with other species of seaweeds and kelp, but nothing specific to our species. So doing those trials and getting those coefficients developed would be most helpful. And then industry needs, we need to establish the standards for labeling and things like that. That's just huge, and address these heavy metals and iodine concerns. Also, occupational hazards. And then hopefully all this can factor in to build and design optimized systems with engineers, processing engineers, and drying technology engineers to come up with a better system for Alaskan kelps. And that is the end.
Thank you so much, Lexa. Wow, that is a lot, and I appreciate you sharing your findings. And we can open up the room to any questions or discussions that folks might want to start. And we've structured this so we have about 5 minutes of presentation and 5 minutes of Q&A. So we really encourage everyone to speak up. And if you would like to just post a question in the chat, I am happy to share those as well. So we have a question from Catherine on which dryer did you use?
Yes, it's a batch dryer. And Karen, I can forward you, I have your email, I'll forward you all the specifics on that dryer. It wasn't the one I recommend be purchased. It's kind of like an aftermarket model, I would say. And it was designed primarily for producing beef jerky, which is not at all what we were doing here. So as far as batch drying systems, it wouldn't be my first choice. My first choice would be going with a batch system from Dehydrators America. And you can look them up online. It's just dehydratorsamerica.com, and they're fantastic. I've talked a lot with their drying engineers and good people there.
All right. Did you use dry from frozen or fresh kelp?
From fresh, yes. We only did from fresh.
All right. And were you drying processed kelp or full blades?
So there was a pre-processing step. Some of it was run through a screw press initially, which reduced surface moisture mostly, not so much interior moisture. And then some trials were just blades that were chopped up by hand. So it just depended on what equipment we had access to. The screw press was a loaner from another project. We were able to utilize it for a brief window for a couple trials. And that also is a maceration step. So it breaks the kelp down into about, 1 inch on the bias pieces.
Okay. And then do you have an estimation of how much your cost per pound for, how much of your cost per pound is labor?
Oh, so that cost that I put up there, that roughly 78 cents, that's just looking at electrical costs. So if you factor in drying, the cost of your packaging materials, your labor, all of that fun stuff, you're looking at just under $20 a pound. And there's things I couldn't put a price tag on, like your rent and utilities and things like that, which will vary, water, sewer, all of that. So I don't know what associated building costs would be, but if you can't factor in labor and your packaging costs, we're doing individual vacuum sealed packages or air, at least heat sealed packages. And so that was about $20 a pound, roughly.
Okay. And next question from Jenna. Is there any significance lost in dust? Did you weigh pre-milled versus post-milled? Is that a concern?
So what we were looking at is we were looking at through the system in a real world scenario, processing scenario, what would you get out of it? And we're running at about between 8 and 9% recovery from weight. So we don't think, and based on the percent moisture content is around that too. We really think because kelp's almost 100% water. We're not losing a lot through the milling process at all. And so we feel like our recovery rates were pretty on par with what we would expected and with other drying. We just wanted to get metrics on a real world scenario. I could have gotten out my my fine balance and measured each bit of kelp dried, but that isn't a real world scenario. I wanted to know just if you're running this as a drying operation, what would your recovery rates be in that scenario?
Okay.
Lots of studies out there that have done that and microwave everything. We just wanted a real world kind of number.
Okay. And did you, for Marcos here, did you find a material dried yield difference between species?
Not so much a yield difference between species. There was a difference in the drying duration. So sugar kelp is really wet and sticky, even going through the screw press with that additional water and surface water removal step. It took longer to dry the sugar kelp than it did dragon kelp.
Okay, interesting. And we'll just do one more question here. Did you have any issues with dust in the drying unit?
Not so much dust in the drying unit itself. The dust came from milling, and the mill has a kind of, cheesy dust collection system, which involves a shop vac, but you still put quite a bit of dust into the air through that process. So that's something you'd want a very sophisticated dust collection system, proper PPE for folks that are doing the portioning and bagging of the product. So every step of the way, once you're done with the milling, that kelp needs to be handled properly so you don't expose people to that occupational hazard.
We'll squeeze in one more here. Roughly how thick a layer did you find worked for drying the shredded kelp?
Roughly about 3 centimeters.
Okay.
Otherwise, you get cold spots, and it was tough to dry. We wanted to keep it reasonable, and doing that in that system, we were able to load roughly 100 pounds of wet kelp onto that rack system. Unfortunately, the rack system was designed again for beef jerky, a really thin product. There's lots of little thin layers built into that cart, and it would have been better if it was designed to accommodate a product like kelp. And you could probably get maybe a little bit of a fluffier layer on there and go for a little longer dry, maybe load a little extra on those carts. But, again, this goes into what are you going to dry? You want a drying unit designed specifically for that product, not trying to adapt an existing unit to that product, if that makes sense.
Right. Yeah. Well, thank you so much, Lexa, for sharing. And yeah, we look forward to the final report and where this takes you next. So
Thank you.
we'll keep moving along just to be timely. And up next we have Johnny with Sequester Farms. He'll be speaking on his project on evaluating infrastructure and seeding methods for scalable bull kelp cultivation. Hey, Johnny.
Cool. Yeah. Thanks. You can hear me all right?
Yeah.
Cool. Yeah. Great presentation, Alexa. Lots of interesting information. I want to know more about the screw press. It sounds like a necessary step. Um, but yeah, so I'm going to speak about our farm operations as well as our also dryer operations, which Alexa, you're a tough act to follow. Your presentation skills are amazing. So I just have the doc here, so we're just gonna go right through it. Got a lot to get through. So our project, we're at this point on schedule, which is super exciting compared to last year. I'm just gonna go through it in the different steps that kind of made sense to me. Hatchery, we did two different types of seeding, spaced seeding. One set was every 10 inches, we had 2 inches seeded, and the other set was every 6 inches, we had 6 inches seeded on the line. Catenary deployment went really well. Feels like we're getting the hang of it. And so no issues there. Catenary seeding, This is kind of what our array looks like. On the right-hand side, this set right here, we have a set of 6 lines that have 6 by 6 inch seating, and those are on normal polypro. They're actually older long line gear that we reused, and 4 of those lines were at 150 spores per milliliter, and 2 of those lines were at the 250. And then the 2 and 10-inch spaced lines, we had 4 of those lines at the 250 spores per milliliter. And then we also experimented with some other lines on another array just to kind of see what might be the difference, though it wasn't necessarily described in our project. Want to see what 4-inch by 8-inch space lines might offer. In addition to that, we outplanted some carbon fiber lines from CCRT, and they're strong, they're thin, they're not very flexible. We're hoping that we get less bowing as the bull kelp grows larger with that. One of the issues we found, though, since they are thin, more wraps probably would benefit from either smaller pipes when seeding or some sort of better wrapping system, way to spin the pipe or something while seeding. A couple of issues that we had with the catenary was our spread of our packages came unhooked. We have since put in locking carabiners and haven't had an issue. Well, we had one issue. One just broke away from the line. The tie down broke. And there's a picture of our growth on the catenary. Everything's looking great. That was February 28th. We went out there the other day, and it's even bigger. And so growth looks great. We've had a pretty temperate winter, and so we're looking forward to a big harvest on that one. The modified peak array, just a quick overview. And I didn't say this, but I should say this. We reduced the amount of the depth that we were testing with the catenary. In fact, we reduced it more than this. From 20 feet, we went to 15 feet. It made a little bit more sense to us just with the issues that we had with depth last year, and just reducing the variability for loss and increase variabilities for gain. And so we ended up doing 15 to 8 feet. Sorry, that number's wrong. And then, yeah. And so that being said, we did the same thing with the modified peak array down tethered to the bottom of the ocean and the bottom of our site, we'll say. And so what we did here, it was kind of a really fun project, is we put in screw anchors and pulleys, and we are able to control the depth of the line by pulling on the anchor. And we've measured depths of 15 feet below mean low tide, and then the center one is supposed to be at 6 to 8 feet below mean low tide. Well, it's supposed to be at 8 feet. It's right now measuring more at 6 feet. It's a little difficult to get those depths right with flotation, and I kind of saw that coming, and so I changed up the project, as you can see, or I changed up the spacing a little bit. As you can see in this diagram right here, there's a lot of vertical movement, which I felt like that was probably going to be too much vertical movement to really get the floats down at the right depth. And so I moved everything about 20 feet away to give us a little 10 extra feet of scope, and that seemed to help. Although it probably could have benefited from another 10 feet just to get that center peak down to 8 feet. On this one, we did 2 lines of 6 by 6 inch spacing at 250 mils per 250 spores per milliliter, and then 2 lines at the 2 and 10 inch spacing at 250. And last we checked, bull kelp is growing the full extent of the line, so it's looking pretty good. Yeah, and there's a picture of Zach, who's a friend of mine, commercial diver, who went in and put our screw anchors in, and it was an amazing feat that everything kind of lined up. He did a great job. And then the People's Long Line. Last year, we didn't have as much flotation as we hoped, so we added floats. We ended up not adding the above monkey fist float for obvious tangling uh, issues. We didn't necessarily want to compromise the bull kelp getting tangled. Didn't want to deal with that mess after discussing it. The deployment went well, though 7 of the monkey fists ended up at the surface at 0 tide, and no growth has been observed on those. While in addition, there hasn't been a lot of growth observed on any of them, but there was possibly an issue with the wafting the monkey fist rather than the direct seed that we did last year. We had some space considerations that we needed to make in the hatchery, so we went with the wafting, and hopefully we'll get some growth from that. And in addition, we had an indigenous intern, Shayana Murphy, from Ketchikan. She came out, helped deploy and seed, and is interested in coming out for harvest. And so hopefully our schedules will work out great there. And I can stop there for questions, but I also have this heat pump dryer that we're working on and I can review too.
I'll open up quickly to see if we have some questions coming into the chat, and if we've got one here from Caitlin. 1 second. What kind of bottom do you have at your site? Rocky, sandy, or muddy?
It's a mixture of all three. The site where we put these screw anchors is a mixture of rock and sand. And so one of the screw anchors we actually weren't able to get all the way down, and so we had to try and get it out and reposition it, which we were able to do and got it to a sufficient depth.
Okay, great. And we do have a comment here about we would love to hear about the heat pump dryer. We do have, I'll put in one question from Dan before you can briefly talk about that. We have a few extra minutes at the schedule goes to 10:45, so if we go a few extra minutes, that's okay. So Dan's asking here, what do you think is a reasonable goal for pounds per foot of bull kelp growth?
I would say anything upwards around the 4 pounds per foot, and hopefully more. I think that if you're asking what I feel like is on the line, I would say upwards around 5 to 6 pounds per foot, at least on the 6x6 array. Not currently, but what we will be looking to get. And this year we're going to get pretty strict yield measurements so that we can really give those a lot of light. And I would say like a great goal would be to be like 8 to 10 pounds per square foot, but or per linear foot. But I'm not positive we'll get something like that.
Cool. All right, yeah, if you just want to take 2 minutes here to go over the heat pump dryer, we can do that, and then we can move on. Thanks so much, Johnny.
Cool. Yeah, no problem. So the waste heat pump dryer is not on schedule. So a little quick overview of this project. We are using a insulated Connex and a heat pump to, and then setting it next to a freezer unit and capturing the waste heat from a freezer unit, using it to heat our heat pump and to see if there's any visible gain of efficiencies in that system. While there's the obvious inefficiency of that we're just using air instead of direct fluid, it's our thought that if we can show some gain through the use of a freezer and using that waste heat, it would warrant a further investment of time and engineering to pipe in that heat into a direct system. And so with that, our drawings have somewhat changed to utilize the full insulated kelp, those insulated conex for the heat pump. So rather than having it externally here, we're going to put in a false wall, shrinking that heated area, and then using this whole area of the conex, probably about 15 feet of it, to pipe in that heated air from a freezer unit. And so we're looking to understand how much heat does the freezer unit, a 20-foot freezer container, put out into a 15 by 8 foot by 8 foot space. And so with that, we'll be able to understand how much heat does the heat pump need, and then kind of go from there. We wanted to try also, we have the option in a nearby building, we have a attic that gets extremely hot during the summer because there are freezers inside of the building. And so we're looking at to also possibly utilize that if we can't see any gains made with just a 20-foot freezer. We just want to see like what gains are possible for this heat pump unit. One thing I'd like to note is, as Lexa was talking about the dust, we are looking at doing a tumbler unit and testing that out. With that, I went and looked at Barnacle's tumblers, and I noticed the immense amount of dust. And the dust is extremely corrosive and has already pretty much put one of their dryers out of line, and they use for parts on the other on their second dryer. And so they have one working dryer because of the corrosive nature of that dust. And so we're going to also develop a filtration system for the air in that. And so, yeah, that is pretty much a quick overview of that.
Great. Thank you so much for sharing. I'm really looking forward to seeing the results from this waste heat pump dryer. It's super interesting.
And the reason that it's not on schedule is because we had some delays with the shipping of our heat pump. That's set to get here in about 10 days. And so it's not ideal, but
Not an uncommon problem up here though. So
yeah.
All right, great. Thank you so much. Let's see. Up next we have Caitlin. She's already here, ready to go. Thanks, Caitlin. And she's here with Native Village of Eyak, presenting on her bull kelp buoyancy assessment project. I'll let you take it away. Thanks.
Thanks, Alex. Can everybody see that okay? I am following up Johnny's excellent presentation on how to grow bull kelp with a presentation on how not to grow bull kelp. So originally our bull kelp project was to look at buoyancy, but the actual title should be challenges related to growing bull kelp. So just real quick, I want to give a quick overview of the Native Village of Eyak because there are a lot of different Native entities in this space. So I just want to clarify who we are, and then I'm going to quickly go over what we were going to do, what we did, and then show you how our bull kelp didn't grow and potentially try to help solve the mystery with a few abiotic oceanography factors. So as an overview of the Native Village of Eyak, the Native Village of Eyak that I work for is the federally recognized tribal government of the area. They create a bunch of opportunities for tribal members while also protecting land and resources, which is where my department comes in, the Department of the Environment and Natural Resources. Our department does a lot of different things, including the Mariculture program. We clean up contaminated sites. We do a little bit of marine mammal work. And then our flagship program is counting king salmon during the fishing season on the Copper River. So originally our project was going to look at how the buoyancy of bull kelp changes over its growing season. This is hopefully to help people like Johnny and other engineers design farms to grow bull kelp. So we were going to monitor the growth, take some buoyancy measurements based on some published methods that are out there. And we have a site. So this is Prince William Sound. Our site is over here in Sheep Bay. Here we are in Cordova. And if I zoom in a little bit, it gives you a better view of Sheep Bay. We thought this would be a great place for growing bull kelp because it's pretty exposed. Most of the kelp farms are in Simpson Bay, kind of tucked up kind of in those enclosed protected areas. But we were like, I wonder if we could grow kelp and bull kelp in a more exposed location to maybe open up some other areas for cultivation. So to grow bull kelp, I had heard people kicking around the idea of trying to grow bull kelp on crab pots. So I thought, why don't we try that out? So we had these 1 meter by 1 meter crab pots made. We put a bunch of this strapping tape on them to create a surface for bull kelp to grow. Added a lot of line to the bottom, attached to a train wheel anchor, and put them in about 80 feet of water. We also deployed an acoustic Doppler current profiler with our partners at the Prince William Sound Science Center. Every time we visited the farm, we dropped a CTD. We measured the individual bull kelp based on the Beaker's method. And we tried to measure the buoyancy of bull kelp first by monitoring the mass of the cages, or I'm sorry, the kelp pots in the water, out of the water. And then we were planning on to measure the buoyancy of each individual. But that didn't happen, and you can see how much it didn't happen here. So on our y-axis, that is in millimeters, and we have data going from April until August. So none of our bull kelp for bulb plus stipe length really got more than, we had one that was maybe about 8 inches long. But April, we kind of knew something was up, and you can see that the pictures tell, I think, a more fun story than the quantitative graph does. And you can see over here in April, or I'm sorry, in February, our kelp were very, very tiny, and I'm really glad that Johnny posted that picture of how his bull kelp were doing last month, because there's a stark difference between our bull kelp 2 years ago and what his bull kelp are doing now. And then in April, over on the right side of the screen, you can see the bull kelp trying to make a go of it. But by July, we had put some of our bull kelp seed string on a different system. And you can see here that it's not very big, how it should be, and it's also very pale. So the density of individuals also cratered. In August, we found one. So that also is an indication didn't grow very well. But we started this project because we knew bull kelp grows on farms in this area. So in Simpson Bay, Noble Ocean Farms has had success growing bull kelp up in the head of Simpson Bay, where there's a huge freshwater lens. It's very protected. There's not a lot of current. But you can see over here on the left, that's our bull kelp in April. And then compared to April 2022 and 2023 at Noble Oceans, they had substantially larger bull kelp. So what happened? I'm going to very quickly run through some of the parameters that we were measuring and monitoring, just to exclude those from potentially what happened. So our ADCP, our acoustic Doppler current profiler, really all I had to go off of was what was in the published literature. And in the published literature, it wasn't much different from what we were seeing at our site. We had currents that were about almost 4 knots, 4.5 miles per hour. In British Columbia, they were seeing similar, maybe just a little bit slower. So temperature, not a lot of published data throughout a season, but in British Columbia in 1996 in August, they were seeing about 60 degrees Fahrenheit water temperatures, same thing that we saw. We also looked at the NOAA weather station buoy 61, that is very near where we collected our sori from the wild bull kelp stocks. And those patterns were very similar to ours. I haven't done the statistics to say if they were perfectly aligned or not, but eyeballing them, they were very similar. Salinity, again, not a lot of published data. There's a high amount of salinity. It's a very saline environment in Prince William Sound before the spring meltwater starts. So nutrient limitation. This is probably the culprit. So we also grow sugar kelp at our site. In 2023, we had an excellent crop of sugar kelp. You can see these nice big long blades. We had some blades that were 8 feet long by June, wonderful, nice and brown. But in 2024, last year, our sugar kelp was pale. so was our bulk kelp. So we were like, yeah, I think this might be a nutrient limitation. And this information is hot off the presses. This isn't my data. This is the Mariculture Recon data. But this is the nitrate and nitrite levels at our farm. And if you take a look in January, February, March, we have a lot of nitrogen in our area, upwards to between 16 and 17 micromolar. But within a span of about a week and a half to 2 weeks at our site, it completely cratered to almost nothing. And we didn't see it start coming up until October. We kind of knew this was potentially the case based on the color of kelp that we saw, but we're still scratching our heads as to why kelp grows so well in other spots and why we had such a good bumper crop that first year compared to this past couple years. And I think the culprit that we're figuring out is we have to plant as early as possible. Our bull kelp we planted in December last year. We also tried again this year, and this year is not growing very well either. So I think if we start trying to shoot for October planting, maybe we'll get our kelp big enough so that it can use this nitrogen pulse as efficiently as possible to get big enough in April so where it can, just have that surface area to suck up as much nitrogen as it can as everything's declining. So yeah, we tried to redo it this year. Things aren't growing as well as we had hoped. I'd like to take a look. There's a bunch of oceanographic data from the Gulf Watch Alaska program, so I'd like to analyze some of that to see if there's other pieces of the puzzle that we're missing. And so this project is more shifting towards the oceanographic conditions that you need to grow bull kelp or you don't want if you're going to grow bull kelp.
Thank you so much, Caitlin. The nitrogen data is very interesting. I was like, wow.
Yeah.
With that drop.
Yeah, and then some of the other
share this through the projects.
Yeah, it's really great that they're letting me do this because, like I said, this is hot off the presses. It's still pretty raw. It's just 1 year, but we're also seeing quite a bit of variability between sites. Potentially, some people are getting a spike in April, maybe from all the storms that we have during that time or something.
I have a question from Lexa here on, did you do any nutrient profiling of the kelp produced?
No, it was all too small. And by the time that we went back out in August, it was basically all gone. The pictures that I have from July, that was a trip that we did with some school students. And by the time we came back out the next month, that had all broke off and it was just stipes that were left.
We have a couple questions here on how were the nitrogen levels measured, and then did the nitrogen concentration drop coincide with the phytoplankton bloom?
Yeah, this is a pretty classic boom and bust cycle for nutrients that's following that spring productivity period. And this is one of the reasons why we can't grow kelp in the summertime here. So we knew that this was kind of the issue. We just didn't realize how big of an issue it was going to be timing wise when to plant and give them enough time to get big enough to help overcome that crash. So these samples were collected directly from the water. We collected water at 3 meters. They were processed at UAF with it's spectrophotometry. They have a very fancy seal analytic system to basically just look at what happens when you add different chemicals, changes the color of your sample, and then you can shine some light on it and actually measure how much color is in the system, which is a proxy for how many nutrients are in the sample.
All right. Thank you so much, Caitlin. We appreciate your presentation. And yeah, I mean, knowing what's not going well is just as important as knowing what does work well. So we appreciate you being so open about sharing all of your results, even if it wasn't what you were hoping or expecting. So we can move on here. Eric's already up on the screen, I see. So he's representing Oceans Alaska and projects on design and comprehensive planning of an Alaskan optimized intermodal freight container based shellfish setting and pre-nursery seed boosting system. So, hey, Eric.
Hi, can you hear me okay?
Yeah, can hear you great.
Okay. So how about if I set the stage? How much time do I have?
You have about 5 minutes to present and 5 Q&A. We've been going over slightly because we
Okay.
have about a 15-minute buffer at the end of the meeting. So that's what we're aiming for.
Okay. So here's the just to do a little background. Okay, so currently, although we've experimented with spawning successfully oysters seed in Alaska, it's all done, all the spawning is done outside. And kind of it's reminding me of the last presentation. The whole process of getting seed oysters, to a size that will work on a farm in Alaska, it's a tricky, finicky business. And so I'm involved, my business is involved on like the nursery level. So that's after a hatchery. And then at Oceans Alaska, we've been, exploring how to optimize to actually have a functional shellfish hatchery in Alaska. It's so it's a pretty complicated equation. So one of the possible solutions that would work here, and I'm going to share the screen if I can, is trying to have, oh no, oh, here it is the solution is it's very difficult to have a standalone shellfish hatchery. We've kind of shown that, I say, in the state and the history, and shown that it's nigh impossible. And that's part of the reason, say, Oceans of Alaska is we're involved in training quite a lot. Have to have about these other revenue streams. But so having very low cost operational parameters and then a high output is for a hatchery is key. And our idea here is to put a full shellfish hatchery essentially into shipping containers. Okay, and we're focused more on called the post set, a nursery stage, so to speak. I'm called it pre-nursery stage. So after a hatchery proper, there's all these size graduations in there until they would work in a nursery, a floating nursery. And what that means is going from completely grown algae, as in a hatchery, to completely wild algae, as in a nursery system. So there, in between that, in those is area to be explored. And there's all these opportunities to add resiliency to our seed supply in those size ranges. And that's what this system here is exploiting. And so I'm going to continue show you on here. We came up, this particular design is using 4 40-foot shipping containers. And what's in them, essentially, and I'm going to scroll down quickly and I'll show you those, is we got to have mechanicals in one. So that means we need to be able to bring in seawater. We need to be able to filter it. Some of it's to ultrafiltration, but filter it. Then we want to put it through, most of it through a heat pump. And there's also a good chunk of it. So there's goes through a heat pump to be heated to be used in the hatchery, in the nursery. And then there's a good part of that. We need to filter that seawater to go through a heat pump. That's where the heat's going to be extracted from. And so this first diagram here is showing, there's a key down here that shows all the different filtration, heating, etc. This is like the mechanical room, and we're essentially taking up one 40-foot container just for that. So that gives us heated water and highly filtered water to do two things. To use the highly filtered water to grow algae, and then use the heated water to have the oysters, your animals, in. So they need heated water, and then into that heated water you put your green water, so to speak, right? Your algae mix. So I'll just scroll down here a little bit and show you what we've got going. Sorry, just a minute. At the end of one of these, we have a small space that's actually going to be a lab space. And bear with me. I'll show you in order here what we're looking at. And I'm trying to be quick. Right here is showing, this is algae production. So what's depicted here these are 250-liter bags. That's a newer way of growing algae in. So what we do is you inoculate these bags, from our, I'll say, algae library, and then you grow them up, and eventually you start and bring some of them on, and eventually bring more and more and more on. So all of these, it's showing right here is a side view, and then right up here is from the top. All of these algae bags are just to produce for the one container that actually has the animals. So oysters are inordinately high feeders compared to any other species. Yeah. So we essentially become an algae producing operation. And what's depicted here is an additional part to these bags. This is the type of systems that we have been exploring, using, and developing at Oceans Alaska. So it's going from Caldwell tubes that were in semi-batch, meaning you grew them in there, it's like in a pot. Then you could harvest maybe half of it and, refill it with nutrients and water and expand that, and then you start all over. In these particular bags, it's continuous production. And what it means is that you continuously drip your nutrient-rich filtered water into the bags, and the algae, which you've inoculated into there, grows until it fills that bag, and then it gets up to the harvest level, and it then overflows with, green water. You collect all those up together, and then you can see depicted on the left of that diagram and is like a yellow triangle. They all go into a tank that then you pump from that into the animal. So it goes into the seawater that's going into the oysters. So I'm going to this has got to be brief here. I'm going on, showing those two algae production containers. And here is well, no, not yet. That's the second algae production. Oh, Lordy. That's right. I passed it by already. Here we go. So what this is showing is from top down right here. I think you can see my pointer. It's showing a top depiction of your normal upwell, downwell, your weller tanks that you would see in a shellfish hatchery, right? With your round silos that have screen in there. So we use that for smaller sizes and gives you the ability to set larvae in there too. And then what you've got here on the side, these are, one of the names is Tasmanian tubes. This is a bottle culture system where you put the seed into vertical bottles at a high density, and then we're feeding those just like the weller tanks with your filtered seawater and the green water's dripping in there. So we're feeding them continuously with algae also. Of course, they have to have more seawater, right, than just the food. They need to respirate, they need to eliminate, right, etc., just like out in the ocean. So, and having it at a higher temperature, it allows us to get the metabolism up and activity for smaller seed, right, for oysters. And they don't, what we're doing, I mean, normally this happens in a hatchery, and here it's essential in Alaska, even to bigger sizes than might normally go to a farm, say down in Washington. Here's just a side depiction showing the same type of bottle system. And in our report, we've got all these pictures because we have the similar type of operation happening at Oceans Alaska already. And this is just expanding on that. So what we're doing is taking the entire type of operation, multiplying the amount of algae and animals, and then shrinking it down into a very small footprint with these 4 40-foot containers, right? They're only 8 feet wide. So
Great.
there we
Thanks
go.
for sharing, Eric.
Questions?
I'll wait a second to see if we have questions coming through. So how many of these you have these 4 containers built, or you're in the process of installing these? That's, I guess I wasn't.
No, you're designing it all. We're
Okay.
having like a shopping list of every item that's in here.
Okay.
And then, yeah, it's all about a design.
Yeah. Do we have any questions from anyone else? Nick's wondering if this presentation is available. Nick, are you talking about this specific presentation that?
Not yet. It will be.
Yeah,
Sorry,
okay.
we're still.
So yeah,
one of the things
go ahead.
we are going to do here in the next month, there's we're calling it Train the Trainer shellfish hatchery workshop at Oceans, Alaska. And we're going to be like presenting though and discussing this with other hatchery experts that they're going to be there. And then we're going to be, finishing up, and then it'll be available.
All right. And then Marcos is asking about the Joint Innovation Project include funding to construct a prototype.
No, it did not.
Right. This is very interesting, and these plans will be super valuable. I'm excited to see things come to life. One last question here from Lexa is, how many people would it take to run this system?
2.
2.
So one of the ideas on this is that it would be able to be used seasonally, and then we can drain the system, shut the doors, and then lower the operational costs. We have to meet the timing for when you can seed oysters works in Alaska. And operationally, you've struggled before of trying to produce seed, say in September or in August, et cetera, et cetera. And there's no way that seed product can be in Alaska that works. You have to export it. So having this containerized, very small footprint allows flexibility in numerous ways. And I'll try to, expound on that. The other in the report, additionally, it could be smaller, right? We started looking at just a one shipping container unit, more for educational uses, but our partner wasn't very interested after that. We focused on this, and because it can be scaled down to some degree.
Okay. Thanks, Eric. We do have another question from Thew in the chat, and I invite you to answer that, Eric, just because we need to keep moving along here with the presentations. So thank you very much for sharing. That's very exciting, and I'll invite Kyle with Ostrea Marine to open up his camera and mic, and he will be presenting on optimizing tumble culture method to improve Pacific oyster quality and reduce labor for shellfish farms in Southeast Alaska.
All right.
So,
Hey
hi,
everyone,
Kyle. Welcome.
hey, thanks. Can you hear me and see my screen? Is
Yes,
that all
we can.
working? Awesome. So yeah, we set out to see if tumble culture could be used as a method to grow oysters in Southeast Alaska. This is a project with Henry Fleener, who you all know, I'm sure, and we had an intern, Liz Roros, who was from the University of Delaware and was a hauling scholar with NOAA. She helped us out a lot with this project. Oops. There we go. So,
Okay, I'm off, April.
okay. So traditionally, this tumble culture method was really designed. It was designed for these large intertidal estuaries or bays, places where you have big tidal flats, not a lot of tidal fluctuation, and you can build these really large scale operations. And there are operations all over the world that this is their primary means of growing oysters. We don't really have a lot of this kind of space in Alaska, especially in Southeast. Um, we just don't have these big bays with flat sandy bottoms that are easy to work. So we kind of set out to see if rather than one of these large operations, if we could build some smaller operations some smaller arrays that would fit into the sort of to the it would dovetail nicely with some of the other growing methods that farmers are using in Alaska. So the basic idea between tumble culture is that these hanging baskets that hang from these lines, they tumble with waves and tides and currents, and they reduce a lot of the need to manually tumble oysters or tumble them in a big oversized rock tumbler essentially. And that tumbling hardens the shells. It removes some of the frilly bits. It also helps with growth, and then and sort of a shell shape or a marketable shell shape, and then the regular exposure to air and sunlight helps with biofouling, and predation from sea stars. So we went with SEPA cages. They're one of the companies out there that are doing it and making these systems. They were super helpful getting us set up. We bought 500 half-inch screen baskets, and we used locally available materials to build the arrays, save for the cages and the lines and the clips. But we had to get a little creative with how we built them compared to how SEPA recommends building these arrays. We set out to try this tumble culture method in a couple different ways. We have an intertidal system, which again is much smaller than you would typically see these systems being used. We tried some subtidal deployments, which is another way that these cages have been used in the past, where this sort of rope ladder system was hanging vertically off of some floats, and the idea is that the oysters would tumble in there, but they wouldn't experience this exposure to air and sunlight that the intertidal oysters do. And then the control was floating bags, which is the standard operating procedure on the farm. We put out 18,000 oysters in 36 cages in the intertidal, 8,000 oysters in 16 cages in the subtidal, and an additional 18,000 oysters in the floating bags and the sort of control standard operating procedure on the farm. We put them out in late spring, early summer, and ran them in these different growing methods through the fall. And these were 1/2 inch screen oysters from Hump Island. At the end of the growing season, we collected subsets of oysters from the different treatments, and then we compared them to measurements of oysters that we had taken when we first received the 1/2 inch screen oysters from Hump Island. So that's this time 0 is this the 1/2 inch screen oysters when we first received them, and then the intertidal, subtidal, and control. These are measurements from the oysters at the end of the growing season. We see that the intertidal and subtidal tumble cages did better. Well, all the oysters grew, which is nice to see. And then the oysters in the tumble culture cages had longer shell height, or had higher shell length, and were deeper than both the controls and the time 0s. The subtidal oysters had higher whole weights than any of the other treatments. But when you look at the wet meat weight, the intertidal oysters were statistically the same as subtidal oysters. And so I think what we ended up seeing was that the subtidal oysters didn't tumble as much as the intertidal oysters. And so all this additional shell growth that you see was like frilly, sort of brittle shell growth. It wasn't hardened shell. And so this difference between whole weight and wet weight is because there was just more shell weight with the subtidal oysters as opposed to the intertidal oysters, but they had the same amount of meat weight. So, and you can kind of see it in the photos. These were collected in a midpoint data collection, so these weren't the final sizes, but the intertidal oysters were really clean. This is how they came out of the baskets, really clean, pretty nice shell shape, pretty hardened shells. The subtidal oysters were not as clean, had this frilly shell growth that I was talking about, and the controls were kind of somewhere in the middle. The intertidal oysters, I think the biggest takeaway here is that is a labor difference. We put the intertidal oysters in the cages in June. We didn't touch them until September. We went and checked on the cages. By September, they had a little bit of barnacle growth on them, but because it was being regularly exposed, that barnacle growth scraped off super easily. We didn't see a lot of mortality or predation at all. The subtidal oysters got hit with a couple really gnarly mussel sets that we had to pull all those ladders out. They were really heavy, laden down with mussels, and we had to pressure wash them, and then the controls take a fair amount of labor. The bags were their floating bags were regularly flipped manually by someone in a boat. And then they were tumbled as well in a centralized tumbler, a mechanical tumbler. So the intertidal oysters did really, really well. I mean, talking about higher meat weight or higher meat weight than the control oysters, the same meat weight as the intertidal oysters, and basically zero labor whatsoever was expended to grow those oysters. So it's pretty promising. And we're going to continue to analyze data from 2024. We have motion sensors on the cages and stuff, so we're going to analyze, working on publishing those findings. We've built one intertidal version, like I'm calling 1.5 in Huna at Kau Oyster Company. We took some lessons that we learned from the from the intertidal array that we built in Juneau, and we applied it to building an array in Hoona. And then like late end of this month or early next month, we're going to build an intertidal array version 2.0 at Salty Lady Seafood in Juneau, which will allow us to track some of these same oysters from this study all the way to market.
All right. Thank you so much, Kyle.
Yep.
Exciting results with the intertidal, and excited to see the next iterations. I'll open up the chat for questions. What were the starting sizes and weights of the oysters?
They were half-inch screen oysters. Though, yeah, they were half-inch, minimum screen, but some of them were almost an inch, probably, I would say. There was quite a lot of variability so if you look at like shell height, for example, you got a fair amount of variability there from 10 millimeters to 40 millimeters. But whole weight for those time zero oysters, so that'd be these time zero oysters here, was the oysters that we received in the beginning. Whole weights were pretty together, pretty tight. There's not a lot of variability in the whole weights. So we're looking at about 2 grams or something like that, whole weight. Yeah.
Great. Thank you so much, Kyle. We have one more here. If there's very limited beaches with the topography for the intertidal system, then how would this be used in Alaska at scale?
Yeah, certainly. I don't think it would work at scale necessarily. What we're sort of experimenting with, or what we're thinking about, well, two different things. One, most oyster operations in Alaska right now are pretty small operations. So adding capacity on a nearby beach that is in addition to a floating operation that is, could contain an additional 20,000 or 30,000, 40,000 oysters is a nice addition, especially if you have that space just adjacent to your farm. A lot of the farms that we've been working with in Southeast have some space like that. So when we went out to Hoona to set up a line at Kau, it's just a one single line that runs along a beach that is adjacent to the floating system there. So rather than being an array like this, it's just a single line that kind of follows the beach topography at the right intertidal level, to sort of, to allow enough exposure to air, but not too much.
Right.
And
I might have to cut you off here because we have a couple more presentations that we
yeah, sure.
Squeeze in. So I invite you to continue the conversation in the chat. I just want to be able to respect everyone's time here.
Of course.
But I really appreciate it, Kyle. And yeah, excited to see how this evolves. Next up, we have Francis with Pacific Hybreed talking on his project on developing improved seed of the Pacific oyster for Southeast Alaska regions. Hi, Francis.
Hello. Let's see. Let's share my screen. Okay. All right. Cool. So Eric already kind of mentioned there that importing and growing seed, it's kind of a very tricky business in Alaska, right? Because pretty much all of the seed are imported from elsewhere, and then it's just very difficult to know if the specific groups of seed that you bring into Alaska is going to do well or not. So I think that presents a challenge and also an opportunity for us to come in and then try to find that specific types of seed that will do well in Alaska. And so this is a general approach that we take. So, but I think in a sort of in a nutshell, it's breeding, right? So we take natural populations. There are a lot really abundant genetic variation in actually a lot of naturalized populations of oysters. And so from that, then we do a pair mating approach, and then kind of assign those different variation into specific families. So typically, this take 2 to 3 generations of breeding, and then in between those generations, it's just a lot of field testing at specific sites that we want to optimize the seed and the broodstock for. And so in this case, we chose Little Port in collaboration with NOAA Fishing in Alaska, because it provides a really nice site to test a fairly I guess a relatively large group of oysters in terms of varieties. So what we did was we deployed 23 different families of Pacific oysters. So each family was produced by mating a distinct male and female. And so all of the animals were genotyped, so we can kind of keep track of exactly the pedigree and lineage. And so the experiment started in April, and there was one sampling point, and then another in July, and then another in September. So what we found was so overall, when we look at overall average, meaning combining mathematically combining all of the groups, what we saw was a doubling of their group weight between April and July, and then there's another doubling between July and September. So the increase was much bigger in between July and September. Kind of went from below 10 to over 20. And so the change in weight was kind of partially explained by the change in water temperature. So you can see there was a slight increase, probably on average about 2 degrees, starting in July. That happened to be our second sampling time point or midpoint sampling point, and then that lasted till September. But at least for based on laboratory studies, for a doubling of growth rate, that probably take about at least 5 to 10 degrees difference, water temperature difference. So the growth here we're looking at is likely because of more than just temperature. Okay. Um, and so like I said, so this figure on the left presents the overall average, and we also have family specific means, and that's shown by the individual dots on the exactly same figure basically, but with the family means. So from those different group weights at different time points, we're able to calculate the yield, which is basically the final weight for that family, and then corrected for any differences in mortality and also in the starting weight. So what we found was the best family, actually the best two family had about the same yield performance. These were for seed performance. So they went into the cages at around 3 millimeters. So over 60% over the lower performing families. And those same family were also deployed in Washington at another beach in Washington. So I think this is a really important result, because what we saw was there was virtually no correlation between seed yield for this same family in Washington versus Alaska. Right? That means these good families that did well actually were not the same family that did well in Washington, meaning we'll need a specific breeding approach, breeding program, meaning specific lines to produce the seed that would hopefully do well in Alaska. And that's going to be what we're going to focus on in our kind of second year of GIP project. And that will be all. Thank you.
Thank you, Francis. I'll invite questions to the chat. Anyone is allowed to use their mic as well if they prefer. We have one question from Jeff here on how did you measure 3 millimeter?
Yeah, so the measurement that I show were all the measurements that I show were group weight. So these were so we weigh, let's say 100, 200 oyster at the same time. And then we could measure 3 millimeters individually by using by putting it under microscope, which sometimes we do. But I think for this study and for most farm testing, I think is more realistic and also kind of reflect of what a farm would do is to measure the whole group and then see how that specific bag kind of oysters in that bag as a group kind of grow as time goes.
And Eric wants a reminder on what size did you start with?
Approximately a 3 millimeters. Some oysters were about maybe 4 or 5, but it's kind of in that range. Is that range you usually import seed into Alaska?
How much larger was the maximum Washington versus maximum Alaska oyster variety?
So Washington growth rate was about 4 times faster than Alaska, 3 to 4 times on average. So
And then what was the
quite
mesh
a bit bigger.
size of the bag?
So the mesh size was 3 millimeters,
Okay.
just enough to retain oysters, and then of that size, and then allow water flow.
All right, great. Thank you so much, Francis, for
Thank you.
your work and report. And we look forward to seeing how your work evolves as well. So next up, we have our last presentation today. Looks like Jeff is already tuned in here. So Jeff is with the Chugach Regional Resources Commission and is speaking on hatchery cultivation of the Pacific razor clam. Hi, Jeff.
Yeah, good morning. I'll be brief. I know we're running out of time here. So we completed this project on time, within the budget, and we kind of achieved and accelerated some of our excelled on our objectives. So we're pretty pleased with the project. So you want to know maybe why razor clams? A lot of what Alutiiq Pride does besides commercial production of cockles and gooey ducks and oysters is enhancement projects. And razor clams used to be the second largest clam fishery in the world outside of Cordova, and it's essentially gone. And the usual suspects of overharvest, mostly the earthquake, changing oceanographic conditions, they're just hard to find. And likewise in Cook Inlet, what used to be a huge fishery, recreational fishery, and an economic driver on the peninsula, Memorial Day and Labor Day with mass of people coming down for the razor clams and the low tides has gone away. Last year, the estimate was about 85,000 clams. So it's not looking real good for razor clams. So Alutiiq Pride back in the Exxon Valdez oil spill back in the early 2000s, we did some razor clam work in Cordova. We planted some beaches and we had some experience with razor clams. And then a few years ago, we worked with Dr. Kelly out of University of Alaska Fairbanks and did some work with some exposure studies with razor clams. So we had a history of working with them. Our goal was to kind of try to refine those hatchery techniques and get to the point where we could produce enough razor clams perhaps to do some small enhancement projects to see if, maybe bring back some localized populations or at least evaluate whether it's a tool. So our biggest obstacle is finding the clams. We spent 15 to 20 man days in Cordova going to all these beaches where people said there'd be these different clams and basically whiffed. We got just barely enough to get back and some were sub-size. But we did manage to get a spawn, which was, very fortuitous. And although the larvae weren't fully developed and they're a lot of irregular shape, we managed to get some through the larval stage and go to post-set. And we actually still have some now. So under the circumstances, that's good. So the biggest obstacle we have with razor clams today, of course, is finding them, and we have a solution for that. But also holding razor clams, because the abductor muscle is very weak, they need to have some turgor pressure, some pressure on the outside of the shell to keep them closed from drowning. And they typically don't last in the hatchery even 4 or 5 days, despite all the different things we do to try to put sand or rubber bands or mesh stockings or things around the clams to keep them closed. They just don't seem to make it. So this year, our larval rearing went as expected. We ended up with, I think, 25,000 post-set clams, which was pretty good. And we had a flood event in October that we had some siltation issues, and we lost quite a few then. But right now, the clams are well over an inch and a half. And because we had the success, and we're just kind of holding them longer just to observe the different kind of techniques we can use to raise them. We've tried to use some calcine marking, which is a project we've been doing recently to try to mark our clams. And it's been successful with cockles and little neck clams. And we're going to find out soon how well it worked with razor clams. Because ultimately, it's going to come down to money. Razor clams move a lot, so you can't just throw them out on the beach like some of the other hard shell clams and go pick them up because they move. I actually witnessed a clam one time when I opened up the lid, a clam popped out and literally swam across the other side of the tank. So that was an observation that you don't typically see. So at the end of this project, then, we're pretty excited. I think the biggest success of this project is we did get a second year funding, but in the first time of my career, which many of you know is pretty long and lengthy, this is the first time that a resource agency like Fish and Game is going to partner with us. So we've already had some preliminary talks this year. We're going to go out. We're going to utilize the staff in Homer, Mike Booz and his folks. We're going to share with them some razor clam population estimates. We are going to collect razor clams from the west side of Cook Inlet and perhaps the east side as well. So we'll have a lot of brood stock. We'll have multiple opportunities to collect a brood stock. And I think our spawning is going to be, and our larval rearing will be much higher. The numbers will be much higher just because we'll have more numbers of brood stock. In addition, we have a study plan we're developing that the Department of Fish and Game is going to basically do for us or with us. So we'll be stocking clams on the east side of Cook Inlet next year, and they do weekly and bi-weekly sampling so we can try to monitor these clams for as long as possible to find them. So that's a huge success to have a resource agency actually participate and to utilize shellfish enhancement techniques, at least evaluate enhancement techniques to see what might happen, to see if it's a tool. So that's huge. The outplanting experiments so far, our goal is pretty modest. It's to have 10,000 clams. So I think that's achievable. And we'll be able to probably track those for 2 or 3, well, ideally for at least a month and perhaps throughout the summer. So all in all, it's been a really successful project. I submitted all the reports. They're online if you want to see pictures. I think many of you have seen pictures of Alutiiq Pride Marine Institute, and you've seen pictures of hatcheries and larvae and that sort of stuff. There's really nothing unique about razor clams with the exception of the broodstock management.
Thank you so much, Jeff. Do we have any questions from the group here? Excited to hear about the collaboration with Fish and Game. Let's see. From Eric, are the PWS and Cook Inlet clams same larval drift zone? Can you plant the same stock in both places?
They're in the same larval drift zone. I doubt it, but there is good news about, because the larval drift zone is a guidance, but it's often not, it's not a policy, it's not a regulation. I haven't asked them that, Eric. It's a great question, but there is research that shows the west side and east side of Cook Inlet are the same genetic population. So whereas the east side, where the recreational fishery is, the populations are really down. The west side, not so much. There used to be a commercial fishery there that went away, but it's a harder effort to get to the west side. You got charter boats and things. So the populations there, Polychrome and Crescent Lake or Crescent beaches are much healthier. And so, yeah, I think if we have a successful production this year, success with fishing game, then perhaps someone might want to transform to Cordova. It's really sad that you cannot find a razor clam in Cordova.
All right, I'll wait a few more seconds here for any last questions for Jeff. All right, well, I encourage you all to, reach out to each other with questions. And I am just once more putting in the chat the Alaska Mariculture Cluster webpage here with the joint innovation projects. All of the final reports that we have in so far are posted up here, and the clipped recordings from this meeting today will be placed in with each project. And thank you so much for your time, everyone, today. We will reconvene on Wednesday. I hope everyone has a great rest of their day and a great weekend. And thank you so much.